Welcome everyone. So this module is about the data types in Python. So what actually is data type? So data type is nothing, it's just the type of data that we are using while programming. And not in programming, in every work that we do, we require some data to work on. And the data is different in every case, depends on the what work we are doing. Like if you are writing a paper, then you need a pen and paper. If you are making some food, you need food. So all these things are different from each other and require as per their need. Like if you want to eat, you cannot eat paper, you just eat food. So that's the thing here. In programming languages also, we use different kinds of data to work on. Like if we want to add any name, we use the characters A, B, C, D. And if you want to do some mathematical calculation, we use numbers. And there are many more different data types in Python that we are going to learn here. And there are some that are similar to other programming languages and some that are unique in Python. So I hope you enjoy this module. Thanks for watching and I will see you in the next video. Hey everyone. So in this video, we are going to cover the first data type, that is the numbers. So let's begin. And that's what we are going to learn in the Python shell. So right here, Python 3. And from now, try to prefer the Python 3 instead of just Python, because maybe sometime 2.7 will appear here. And if you write 2.7, then there are some differences in Python 2 and Python 3, so you may get error. So to avoid error, just write Python 3. So first of all, what do you understand by the numbers? Numbers are just 1, 2, 3, 4, 5 and 6, all that. And this is 7. So these are the numbers. And this is our first data type. In Python, you can do anything with the numbers. Like you can just store them in any variable. You can use them wherever you want to, like y is equal to x plus 3. If you print y, then we have 7. So this is the numbers in Python. So they may just generally include all the numbers. And if you try to find out their type, like we use the type function to find out any data type. So if I have x, you will get int. So that's the type function here. Now if you have x is equal to something 3, y is equal to 5, you can perform arithmetic operations on them, like x plus y is equal to z. If you print z, then you get 8. Or you can directly perform 3 plus 5, 8. And one more thing here, if you use something like 8 by 3, you will get 2.6665. And if you use 8.0 divided by 3, you will again get this thing. But if you use the Python and do something 8 by 3, you will get 2. That's the value in int. It may round off the values after the point and will provide you only integer type. And if you do something like 8.0 divided by 3, then you will get this result. So that's what a common difference in Python 2 and Python 3 is, that Python 2 is more accurate in calculating the values and just prefer to provide the result in the value that is more accurate instead of providing the value in which you are performing the calculation. Like I'm performing the calculations in int type and I'm getting the result in a floating point value. But in case of Python, the int floats are not different data types. Like in C, we have int float, long int, float, double, etc. They are all separate data types. But in Python, we will consider all these things in numbers. So now exit this one, and here let me first clear the screen, and now we have Python 3 here. So now this is all about the numbers, and you can also get the type of these things, like 8 divided by 3, I have float. Here you did not get int, because as I have told you, in Python int and float are not the different data types, they just fall in numbers. That's why in both the cases when we are calculating the number, first we get the int and now we have the float. So that's what all about the numbers, I think, and in the next video we will learn the operation on these numbers and some methods to change the types like from int to float, etc. So thanks for watching and I'll see you in the next video. Welcome everyone. So in this video we are going to learn about the operations on numbers. So basically when we do our regular mathematics, like if we have to find the x, that is the common lowest term in mathematics, then like I have 3 plus 5 multiplied by 6. Here I need to find 3 plus 5 and then its product with 6. So generally I need answer like 3 plus 5 15 and then 15 6 90, but let me print this one also, x here, command s, and when I try to run this one, python and then variables dot py, I will get 33, and that is not even close to a desired result. And now the question is why this happened, because even when I have written plus symbol before the multiply symbol, then why this happens? This is because of associativity and precedence in these things, that is plus and star here. So in general mathematics we have some arithmetic operators. We will learn about the operators in the next module, but before that we have something known as arithmetic operators, which include some basic operators, like if I tell you some of them, like plus, minus, and multiply, that is shift 8, and divide, that is this backslash symbol. So these are the 4 basic arithmetic operators, and 2 more that I want to teach you here. One is power operator, that is the power, like 2 raised to 2 is equal to 4, 2 raised to 3 is equal to 8, that is we can say that square, cube, and all that. And one more thing, these parentheses, these are not the arithmetic operators, but also they are important here. So precedence of arithmetic operators or the operators means that which operator is considered first in any expression. Like here I have these things, and let me open a Python shell here. So here if I have Python, and if I need to find x is equal to this one, 3 plus 5 star 6, and I am getting 33. Sorry, here I have indentation error, and let me remove here this. Now 3 plus 5 multiplied by 6. Here it's not showing result. Let me again open this terminal. What I want to tell you here is that if I have operators like plus, multiply, and if I also consider minus, 4, and then divided by 2, then in these operators some operators has higher precedence than others, which means that some operators, if in the expression at the same algebraic expression, then some are considered first before the others. And the order is, if I talk about these 6, so first is this brackets, then we have power operator, then we have multiply and divide on the same table, and plus and minus on the same one. So if I want to do this thing here and I need the result, that is 90. So I think if you remember this one, I erase this one here. So if you want this one to 90, so what I have here, I have a plus symbol and a multiply, and multiply has higher precedency. So first it will multiply 5 into 6 and then add 3. This is something that is pre-programmed in the programming languages, and someone cannot just modify this one. So we can just do the things like we can add some other operators in this, and so that we get the result that we desired. Like if I need 19, that is 3 plus 5 8, and 8 star 6 48, not that, we need 48. So how I will get 48? If you remember, before multiply we have two operators, that is power operator and the brackets, but the power operators cannot help us in this situation. So if we have some operator that is on the lower of other operators in precedency, like 5 is lower than multiply in precedence table, then we use the brackets, because brackets are the top on the priority list. So here if I have 3 plus 5 and bracket and then multiply 6, and I will save this one, command S, and want to run here, I will get 48. So that's the thing here. And let me take another example, like I have something that is x is equal to, first I need to add two numbers, that is 3 plus 5, and let me do this same with y. And here on the above I'm just writing this one simply, and then I want to multiply this whole with, let me have 2, and then we need the power of that product to 2, so I need the square of this result, and then let me divide this one with 16, and that's what I need here right now. And in last, let me also minus this one with 1. So what I'm needing here is like 3 plus 5, that is 8. 8 multiplied by 2, that is 16, and the power of 16 is 256, then divided by again 16, then we have 16 again, and if we minus 1 from that, then what we need here is the 15. And we have again done that same mistake, because this one is not our general mathematics. And if I do this same with using the brackets, like first I need to add 3 plus 5, and then I need to multiply that whole with 2. But now again I have power that have more precedence than this one, so I will again keep this one in a bracket. Now after that, with this result, what I need to do here is I need to square this number, and then I have divide. Now here I will not put brackets, because divide is already below the power operator. That's what I also need to teach you here, that divide is less than power operator, so that thing is not required. And then again I have minus 1, so here minus is also lower than the divide one, so again I don't need any brackets here. I just need brackets where the first one is lower than the second one. So if I run this 2, then what will I get? Here I have command S, and here I have 3 and 15. So 15 is what we required here, that is the output that we need to generate here. But here we have 3, that is not even again close to this one. And if you try to build this one, how will we get 3? So first it has done 2 raised to power 2, that is the highest precedence operator here. So 2 raised to power 2 is the 4 that we have here. And then we have multiply and divide symbols. So what had happened here? So if you consider the star and divide, then if we have the same operators, then we do the left to right precedency. I think you understand that what I want to say here is, like here I have multiply first before the divide. This thing is left to right, like left here, this is the left part, and then I am coming right. So here I have left to right precedency. So I will consider the operators that are in left first than the right ones. So here I have 5 star 4, that is 20. And then I have the divide operator. When I divide 20 by 16, I will get something like 5 by 4, that is equal to 1.2 approx, that is 1.2, and this whole is in integer value. So what I had to teach you before, like I always get floating point value if I consider that thing point, but in case of this precedency I will get 1, not the 1.2. That's because if I have something like 3.4, and if you have studied physics, then most of you are familiar with the round off figures. That is, if the value after point is greater than 5, then the previous value increases by 5. Like if this one is 3.6 maybe, then the output will be 4, and if it is 3.4, then the output will be 3. That if it is lower than 5, then the output will be same. And if it is 5, exactly 5, then it will focus on the term that is after this one. If the term is odd, then it will increase by 1, and if the term is even, then it will remain same. Like it is 3.5, 3 is odd, so it will become 4. That's the round off terms. So here that thing became 1, and 1 minus 1 is 0, and we are left with 3. So that's how we get the output 3 here. And I hope you understand these things. This is a little something complex one, because it includes some mathematics and precedences. So I suggest you to go through this video again so that it will be clear to you. And that's enough for the operations, because it's just about the precedency of the operator. If you understand the precedency, you will make any calculation right in your program. And if you did not get the precedency, then I surely suggest you to go through it again and again until you get this one perfectly, because that's the most important thing required in any calculation in the Python programming. So thanks for watching, and I will see you in the next video. Hey everyone, so in this video we are going to learn about the restrictions on variables and the dynamic typing. So first of all, we have the dynamic typing, and what that actually means is like something. If I have a new Python file here and save this one like very fi.py, and now if I talk about the variables, then you remember like I have x is equal to 5, something like that in the previous example, and then I have made changes like x is equal to something else, and not, if you not consider that one, just like consider name is a variable of students that stores the student names in the database, and first you assign that one like Dev, and after that the record for Dev is managed, and you need to write another name. Then you will just give another name like we have Alex to the same variable, and that's what its value is changed. That thing is the variable. And now not only Alex, I can just write this one as 23 also. The 23 is then saved in the variable. What I want to show you here is like in other programming languages, like if I take the example of C programming language and just the part of declaring the variables, then in that we have to declare the variable before using the variable in the program, like int a, that specifies that a is an integer and can store only integer values. And if I store in a something like a is equal to 5, then it will work. Again, if I made the same like in Python, a is equal to 12, 13, I have changed this value, this will also work. But if you do something like a is equal to, here you have the Alex, and you try to run that thing, then it will not work. So this thing is the static typing, which means that if you assign any variable its data type, then that data type will remain same, it will not change. Or a a variable that is in one data type cannot store the value in other data type. Also, if it's a int, it cannot store 5.0 in that language. But if we talk about the Python that I have shown you here, like first I have some name and then I have changed that name, they both work. And also if I do something like this one, it will also work. So this thing is referred as dynamic typing, that it's not necessary to define any variable its data type. You can just use the variable and store the data in that data type. So that's the thing here and is known as dynamic typing. This one is not of much importance, but that's just you need to know that what's dynamic typing and what's static typing and what's the difference in them. So I hope you understand this one, that what the thing is. Now another concept here, the restrictions on variable. And restrictions on variable doesn't mean like you cannot define the variable. It just means that how you can define the name of the variable. Like if I have x is something like 13, then it work. If I have x underscore 1, it will also work. So there are some particular rules, like in any variable name, you just use the symbols A to Z, capital A to capital Z, the numbers from 0 to 9, whatever you want to, and underscore. But you cannot use something like @ in any name. You cannot use percentage. So that's some restrictions on variable names. So try focusing on the variables name, that you do not use these kinds of structure there, otherwise you will get an error, and sometimes you are not able to get the cause of that error in that case. So you can define variables name, like if I need to store something like store entry, then I will just either use store entry, and if I use to store the data in track 1, then store entry 1. You can also use something like store underscore entry to separate these two, and underscore 1. This will also work, but you cannot do 1 store underscore entry or something like 1 store entry. The thing here is you cannot use the numbers in the beginning of any variable name. You can use the underscore, like underscore store underscore entry underscore 1 2, whatever you want to, but numbers cannot be used in the beginning of a variable name. So that's the rules here, and these are basic rules. So again, this one is just you need to know, that's why this video is made. So thanks for watching, and I hope you understand both the concepts of dynamic typing and this one, restrictions on variable names. So thanks for watching, and I will see you in the next video.